A Honda Civic travels in a straight line along a road. Its distance x from a stop sign is given as a function of t by the equation x of t equals alpha t squared minus beta t cubed, where alpha is 1.5 meters per second squared and beta is 0.05 meters per second cubed. Calculate the average velocity of the car for each time interval. Okay, so I'm going to rewrite the distance equation, partly to give myself time to think. A is alpha squared minus beta t cubed. I'm going to draw a picture, not really as a delaying tactic, just kind of see what's going on. The overly intricate car, though, that indeed is a delaying tactic. So we have a stop sign, we have a distance towards it, and we're trying to find the average velocity. So one of my first thoughts is velocity is defined as the derivative of position x, in this case of t, with respect to t. So we could find the derivative of this to find the acceleration, or the velocity. So that would be 2 alpha t minus 3 beta t squared. And if we wanted to find the average acceleration, or average velocity, what we would do is we'd take the integral of this over this time period and then divide by the distance of the time period. So if we draw this out, it'll look something like, let's see, this will be velocity, time, and velocity might look something kind of like that. It's just me drawing a picture. And so the idea with the average then would be is if you looked at this as all the area under the curve, and then you reformed that area to be a square, that would give you the average velocity. But an easier way to do that would be, instead of taking the actual derivative, we just look at this instead as delta x delta t. And that will give us the average. It won't give us the exact, but it'll give us the average. And so all we really have to do then is find a whole bunch of delta x's. So for 0, 2, and 4. So 0, 2, and 4. So what we're going to do is we're going to find x of 0. And the idea is when we're doing this big delta, and instead of the d, so this means a finite difference. This means an infinitesimal difference. When we find this finite difference, what we're doing here is we're finding the average velocity. So x of 0 is going to be, let's see, x of t, I'm going to rewrite that one time, or at least one more time, to be 1.5 t squared minus 0.05, I think it's 0.05, yep, t cubed. That way I can see what it's going to be for each of them. Go back to the blue. This will be 1.5 times 0 squared minus 0.05 times 0 squared, which will give us 0. X of 2 is 1.5 times 4 minus 0.05. 4 is 2 squared times 8, which is 2 cubed. So we have 1.5 times 4 minus 0.05 times 8, which gives us 5.6. Yep, I'm good with that. 5.6. X of 4 equals, Wait a second, I'm going to write this out. 1.5 times 16, which is 4 squared, minus 0.05 times 64, which is 4 cubed. And so we can do 1.5 times 16 minus 0.05 times 64. We get 20.8. So we want to find the difference between 2, 4, and 2 and 4. Okay. So to do this, not too bad. A is going to be the average velocity between 0 and 2. So that would be 8 minus 0, delta x, over delta t, which is 2 minus 0. So we have 4 meters per second. B is between 0 and 4. So we have 20.8 minus 0 all over 4 minus 0, which is, I'm going to actually have to use it. Oh, wait a sec, 5.2. I can do that. 5.2 meters per second. And then for C, which is between 4 and 2, we have 20.8 minus 5.6 all over 4 minus 2, which is, it's going to be 15.2, I think. No, 14.2. I think it is 14.2. I should do the calculator. 20.8 minus 5.6, 15.2 divided by 2, 7.6. 7.6 meters per second. And that is how you would use this distance equation to find the average velocity over a period of time. So not too bad. Pretty reasonable question. I like it. Hope that helped. See you next time.